Hey guys, it's Mike here. I just want to show you a little bit in detail look of one of these projects, or excuse me, one of these lessons I designed in this project that's going to help kids with the idea of gravity. In any game or in any movie that you may see, needs to be realistic. For instance, we have this pen here. You want it to actually look like it's a pen dropping in real life. This is real life. But when you animate something, you want it to make it look realistic. So in this lesson 3 here, kids will be exploring the idea of gravity, how we can model gravity, and the big difference that in gravity things accelerate, velocity changes, as opposed to a car on cruise control where velocity may just stay the same. How am I going to get at this key concept as well as a host of other graphical concepts and modeling concepts that are present? I'm going to use a motion sensor. So in the activity section of this website where I showcase all my stuff, you can click right here, the motion sensor lesson, and this is what students will be working on in order to, my hope is that they gain deeper mathematical understanding in terms of graphical concepts, and I also want students to have a clear understanding of the distinction between constant velocity and acceleration. So what this really looks like is we're going to be using a motion sensor. I talk a little bit about the motion sensor at the start of the class, how it collects data, it uses sonar, but besides that we're going to get right to the point, and I'm going to ask students to be the objects in motion. So students will be working on this page while Joe, for instance, moves. What do you notice about the graph that's going to be set up on the projector before Joe moves? What do you anticipate? I see a graph. I see it's measuring position and time. Could be something they notice. While Joe's moving, the motion sensor is going to actually track in real time Joe's motion, which is an incredible graphical concept showing that a graph tells you information. Where is Joe at a certain time? They give you tons of times, tons of points. It's all great information. A key concept that I really want to hone in on in this lesson for students. So there's the big idea there. Students will actually be calculating data here for Sally's movement. Where does she start? Look at the graph. When was Sally 5 feet from the motion sensor? See if you can read a graph and really ingrain that understanding. That's going to be day 1. We really just want to get at the motion sensor, what it looks like, stuff like that. I'm going to let various students try it out, but I'm going to tell kids to, without using the vocabulary we're going to use on day 2, to move at the same pace, a constant velocity. In day 2, we're going to be introducing gravity, and how I'm going to do that is have Amelia and Sam, for instance, move away from the motion sensor. Amelia will go at a constant rate, and Sam will go, I'm going to tell him to slowly speed up away from the motion sensor. Go through all these questions, and we're going to see things. And down here in this table, I'm going to have them, draw the person's graph, sketch it out. How does the graph look? For Amelia, it's going to be a straight line, a constant rate of change. For Sam, it'll be increasing, where the velocity is not constant. I can pull up this velocity time graph right here, and they'll notice that the velocity time graph for Amelia will be constant. It will be a straight line. But for Sam, it will be increasing, coming to the big conclusion, the big idea, that when objects fall, their velocity increases. Thus, the big picture idea for this lesson is now that students have the understanding that velocity changes when we accelerate, and that same idea can be modeled with gravitational situations. We can introduce the fact that if we can just get velocity to change in our sprites in Scratch, while we're out here, Scratch projects, we can create objects that fall more realistically, that is, fall with gravity. Hope this will be a great, fun project, get them on their feet, different technology, and hopefully there'll be a lot of takeaways from it. Thank you.